Alright, time for section 7.8. We're talking about infinity for a while here. Infinity sort of worked its way into the fact that when we did approximate integration, the limit at infinity would give you the real value of the area found. But now we're talking about something called improper integrals. There are two types of integrals that involve infinities, and they're just called improper because real numbers don't really include the infinities, but you can still work with them as long as you take limits. Alright, so the first one is where x goes to infinity. That means that we're taking an integral over the x-axis, and we want one of the limits of integration to be infinity. So our example, let's see, we have a couple of examples. I'm going to do on the next page the 1 over x squared, but I'll start out with this one, the integral of 1 over x from 3 to infinity. Alright, so what does that, how can you actually work that? What it means is that we need to introduce another little variable. It's a t. This has a, yeah, there it is, t underneath. Just looks a little funny. Limit as t goes to infinity of 3 to t. So that replaces the infinity with a variable that we can then take the limit of after we do the work of 1 over x dx. And then you just do the integral as normal, so you get the natural log of x. I didn't put the absolute values on there because in this case x is positive anyways, goes from 3 to infinity. From 3 to t though first, and keep that limit as t goes to infinity out front. Then you get natural log of t minus natural log of 3, and finally you take the limit. So then you have to use the calc 1 skills of taking limits. And in this case, it's basically just knowing what the graph of natural log looks like. It goes up forever. As t goes out to infinity, natural log of t becomes infinity. And then you can replace the natural log of t with infinity, and infinity minus a small number, like infinity minus natural log of 3, is still infinity. So the answer to this problem is infinity, and we say that the integral diverges or is divergent if the answer is infinity. So I went ahead and did that one first, but now let's see one that gives an actual answer. Alright, here's the integral from 1 to infinity of 1 over x squared dx. So the x squared here, spoiler alert, is that has a high enough power on it, x squared, makes it go down faster because x squared gets bigger faster. And so it approaches 0 real quick. And that makes it so that the area under the curve is actually finite. It gets an actual value. So let's see how that works. You take the limit as t goes to infinity, 1 to t, 1 over x squared dx. The antiderivative of 1 over x squared is negative 1 over x. I did that a little fast in my head because x squared, 1 over x squared is x to the negative 2, and then you can raise and divide that. So you can raise it to negative 1, divide by negative 1, and so that's what we have, negative 1 over x. And now I plug in, I take the limit. So I take the, let's see, what did I do? Alright, first I plug in the t and the 1. Negative 1 over t minus negative 1 over 1. Then I can take the limit. So negative 1 over 1 minus gives you a plus. And then plugging t equals infinity into negative 1 over t gives you a 0. That you can know from the picture or from rules about rational functions. Whenever you have a higher power on the bottom and you go to infinity, it immediately is 0. So I get 0 plus 1, and the answer is actually 1.